Okay, yeah, let us focus up in this first example. Okay, what are you are being asked, guys, to graph this rational function. Okay, when graphing rational function, the first thing, guys, that we have to be aware of is which case are we gonna deal with. Okay, can someone tell me what case is this? Case what? The degree. Okay, this is how you can identify one case of another one. That is how we make the difference between them. The degree of the greatest degree here, guys, take a look, that is x squared. And what is the greatest degree in the denominator? It's 1, right? Okay, this, guys, the top is greater for 1 unit than the bottom. Okay, which case is this? 3.1, right? Okay, and what can we do, guys, with this 3.1 case? Okay, we can say we can find a vertical asymptote. Can someone help me? How do I find a vertical asymptote? This never changes, actually. How can I find a vertical asymptote in this case? Okay, it's gonna be something pretty simple. I'm gonna take that denominator and I'm gonna set that equals to 0. Okay, this is exactly the same thing in first, second, and third case. Okay, and my goal, guys, is to let the x alone because I need to figure out what is the value for x. Okay, 2x. This one, guys, is pissing me off. Okay, so I'm gonna put -1. And I notice that x is not alone yet. Okay, I'm going to this 2, guys, which is multiplying on the other side. It's going to be divided in all my terms. Okay, finally, my x is going to be -1/2 in decimal, guys, because I'm going to need the decimal form. That is going to be -1/2 is in decimal form. It's 0.5. Okay, this is my vertical asymptote. Thank you, thank you, thank you. Okay, what about um, the horizontal asymptote? I just want a volunteer to tell me what is a horizontal asymptote in the case 3.1.
There's no horizontal asymptote.
Thank you very much. We don't have horizontal asymptote. Okay, that's why, guys, we need to identify the case because according to the case, we want to know how we're going to find a horizontal asymptote, or specifically in this case that we don't have. Okay, we don't have horizontal asymptote. And what is the other the asymptote that we're going to need? If we don't have horizontal asymptote, we're going to need a oblique or a slant asymptote, oblique asymptote. And how do we find a oblique asymptote, guys? According to the theory, how do I find the oblique asymptote? If you don't remember, let's get back to this. Okay, I didn't mention it actually. Okay, it's gonna be pretty simple. Okay, the oblique asymptote, guys, is gonna be found by dividing this numerator over this denominator using the long division. Okay, this is what we're gonna do, Mister. But someone might ask, Mister, what if I wanna factor this and perhaps I can cancel it? That is a good question, actually. But guys, if you try to factor this, usually this is a prime trinomial. If you try to factor this, guys, you're not going to be able to do it. You can use trial and error to factor this out, okay? If you're, I mean, you're a little bit inquisitive, you can try, you try to factor this by using the trial and error, and let's see if you can, I mean, cancel with this. I'm not gonna do it because of the time, but you can try, guys. You can try to factor that, and you're gonna see that it's not possible. Most of the time, it's not gonna be possible. Okay, let's find the oblique asymptote. Okay, how do we find the oblique asymptote? Well, let me choose another color here. Okay, it's gonna be something straightforward. Okay, what we're gonna do, we're gonna take that numerator to x squared, guys, plus 3x plus 2. Okay, I'm just taking this, and I'm going to divide it by this. Okay, using the long division, guys. Oh, this over 2x plus 1. Okay, I'm going to zoom in here in this part because this is where I'm gonna work. Okay, how do we divide, guys, using the long division? I hope you did the videos that I shared with you because I'm gonna do it. What do we have to do? The first thing, guys, is to take this, the highest power over this. Okay, we're going to divide 2x squared over 2x. If you can do it mentally, great for you, but I can't. Okay, I'm gonna do it here. Okay, 2x squared, this one, over this. 2x squared all over 2x. I repeat, this over this. Okay, and what is that equals to, guys? Help me. If you have 2 over 2, it's going to be 1. X squared, guys, over x, you copy the base and subtract the exponent. 2 minus 1 is 1, right? Okay, this is what we're going to get, guys, 1. Okay, I'm going to put that here. Okay, let me see. I'm going to get just 1x, sorry. I was just putting 1x. Okay, I repeat, I just divide this over this, and I just get 1x. Okay, I put it here. And now let's multiply. It's like the long division when dividing whole numbers. Okay, x multiplying 2x. Okay, x times 2, guys, is going to be 2x. Okay, 2x. 2x what, guys? 2 times 1 is 2, right? X and x, what I get? X and x is x squared. Excellent. Let's multiply this and this. Okay, x plus 1, guys. 1 plus, sorry, times x. 1 times x is a multiplication. I get 1x, right? Okay, all of them, notice that all of them, guys, are going to be positive, right? Okay, I'm going to put positive here. I'm going to put positive. But do you remember, guys, when we divide even the whole numbers, we used to subtract, right? Do you remember that we subtract what we got? Okay, in this case, we have to do the same. But I taught you using a trick. Do you remember that? Instead of putting the negative in the parentheses, we can distribute this negative here. And what is going to happen? We're going to change the sign, right? Okay, we're going to change the sign. But if you want to do it like following step by step, you can do it. Take a look. This is positive, guys. Now it's going to turn into negative, right? Okay, negative. And this is positive, guy. Now it's going to turn into, what is the opposite of negative? The positive, sorry. If it is positive, now it's going to be negative. Okay, just that, guys. Okay, I just changed the sign. And now let's simplify this. Okay, we have 2x squared minus 2x squared. 2x squared minus 2x squared, guys. It's going to be 0. Okay, let's continue. Positive 3x, guys, minus 1x. Okay, you have positive 3 minus 1. We're going to get positive, right? Positive 2x. Okay, and what do we used to do, guys, with the next term? It's like the long division, guys. Okay, we drop this number down, right? Okay, we're going to drop the plus 2 down. All right. Okay, now, guys, it's time to divide this. This is the greatest expression that I have over this. Okay, let's do that. Okay, this 2x is 2x. I'm going to copy 2x all over this 2x. What is 2x equals to 2x, guys? That was easy, right? The same over the same thing. It's going to be just 1. Okay, it's 1. 2x over 2x is 1. Okay, I put it here. Now let's multiply this over this. Okay. 1 times 2x, guys. Pretty simple, right? It's just 2x. And 1 times 1 is going to be positive 1. Thank you. Okay, the line. But we have to put the negative again. Okay, negative. Okay, subtract this. But I don't like to do it like this, guys, to put the negative in all of that. Okay, well, instead, what I'm going to do, I'm going to change the sign of all my terms. Okay, that's exactly the same. Okay, this 2x, guys, is positive. Now we're going to turn it into negative. This is positive 1. Now it's going to be negative 1. Okay, that's the only difference. Okay, negative 1. And now, guys, let's simplify. 2x minus 2x. What is that equals to? 2 minus 2. 0, right? Okay, it's always going to be 0. And 2 minus 1. 2 minus 1, which is positive 1, right? Okay, and we finish. This is the remainder. Okay, I don't care about that. Okay, guys, can someone tell me what is going to be my oblique asymptote? Okay, the quotient, guys, of this. This is going to be my oblique asymptote. Okay, let's say y, okay, y, what I use green, y equals to this expression, guys, because it's an oblique asymptote. We're going to have in a slope. We say y equals to x plus 1. Okay, let me see. X plus 1. Okay, I'm going to highlight this because this is an important information, guys. Okay, any questions so far? Do you remember when we were, dividing using the long division? What is this used for? Now you can answer that. We used to graph rational function. That is a tricky thing, guys, about mathematics. Anything, guys, everything you learn, guys, some days, somehow you're gonna use it. Take a look. I think that maybe you I mean, you told yourself, what is this useful? Or for what I'm gonna use this? Take a look now. When graphing, we're using that. Okay, this is the my oblique asymptote. But guys, if you watch the video, how can I graph this? How do I graph this function? We can use a table, guys, but oh my gosh, that is hard. That is a little bit tedious. In that video, guys, I taught you a way that is called the slope-intercept form, which is really simple. What you have to do, you only need to identify a slope in y-intercept. I call it like this, y-intercept. Let's see if you watch the video. What is the slope in this case? Can someone help me? What is the slope in this function?
It will be 1 over 1.
Excellent. Oh, amazing. You assure me that you really watched the video. Excellent, Freddy. The slope, guys, is the coefficient of the variable x here. Is this number here, okay, which is 1. But Freddy told us we need a fraction. Okay, we're going to need a fraction. Okay, when you don't have, in this case, that you don't have fraction, you only add a 1. Okay, that's it. And another thing that we have to know is that these denominators is a change in the y, and this denominator is the change in x. Okay, with this information, guys, we're done. And what is the y-intercept? The y-intercept, guys, is always the constant term, even in the quadratic function. Do you remember? Okay, what is the y-intercept? It's 1, 2. Okay, with this information, guys, in our hands, we are completely capable of having this graph. Okay, well, I'm gonna give you some time to make the coordinate system, and we're gonna work in the graph. Okay, we're gonna try to graph, guys, the vertical asymptote and oblique asymptote. Okay, let's start off with the vertical asymptote. What is the vertical asymptote? Here's the value, guys. X is equal to negative 0.5. Okay, vertical, guys. This is a vertical. Okay, something up to down. Okay, vertical. Asymptote x 0.5. Okay, let's look for x negative 0.5. Okay, this is 0 negative. It will be between 1, negative 1, and between 0, right? It's going to be a point, okay, actually here. Okay, I'm going to try to make that point. Okay, I'm going to use the white color. Let me see if I can get that one. Okay, let me see. The point is going to be something like this. Okay, now I'm going to make that my vertical asymptote over there. Okay, let me see if I can do it. Okay, it's, oh my gosh, that is not. Okay, something like this. X equals to negative 1/2. Okay, that is the values. X equals to negative 1/2. Okay, that is my vertical asymptote, guys. And what about my, I don't have horizontal asymptote. Okay, I don't have a complete horizontal asymptote. However, we have an oblique asymptote. And what is that, guys? X plus 1. Okay, this is the linear function. But what is going to be, in this case, what is going to be my, how can I graph that? Okay, by using this information. Okay, the first thing that we know about this graph, guys, is that y-intercept is in 1. Okay, what the intercept, guys, is where the graph is going to cross or touch one of the axes. In this case, the y-axis. Okay, this. What is going to cross in this graph? In 1. Okay, y equals 1. Where is y equals 1? Okay, it's going to be this point. Okay, let's make it here. Okay, y equals 1. I'm going to use this blue color. Okay, in this point, guys, in this point, right? In y equals 1. And what is the slope for this function? Is 1 over 1. Okay, this means, guys, the numerator, okay, from this point, you're gonna I mean, you're gonna be in this point and you're gonna move according to the slope. The slope tells you move 1 unit in y. Okay, 1 unit in y. Okay, let's move 1 unit in y. Okay, 1 unit in the y. Okay, okay, I stop here. And now let's see the denominator. How many units do I have to move in the denominator? 1 unit in x. Okay, in x, always to the right, guys. Okay, in here. I repeat, 1 unit up and 1 unit to the right. 1 unit up, 1 unit to the right. And this is where my second point is gonna be. Let's make the second point here. Okay, now guys, I'm gonna make the line. Okay, I'm gonna try to make this straight line here. Okay, this is my line, but this is not a, I mean, this is not a solid line. It's gonna be a dashed line since this is a, I'm looking for an asymptote, right? Okay, it's gonna be in a slant, um, a dashed line. Okay, I'm gonna dash this line. Okay, for me, guys, it's not gonna be difficult. I don't know how you can do that on your notebook, but I'm gonna just dash this out. Okay, and this is my oblique asymptote. Okay, if you want to add this information, guys, it's not required, but if you want to be a little bit, I mean, a little bit picky, you can do it. Okay, what is the graph for this? Y equals to x plus 1. Okay, that is the function, right? Okay, take a look. Y equals to x plus 1. If you want to add more information, it's not necessary. That's it, my students. Next is to use the table. Okay, okay, we need a table to take some values. Okay, because I don't know how the graph is, if the graph is gonna be here or here, here or here. I don't know. Okay, with the table, guys, we're gonna find that out. Okay, I'm gonna try to make a table, a decent one. Okay, this table. Okay, and we're gonna substitute some values here. Okay, I'm gonna take two values to the right and two values to the left. X, Y, and what is my function, guys? Okay, in the middle column, we need to put a function. Okay, remind me this function, please. This one. Okay, I'm gonna need it here. Can someone tell me? 2x squared. This is the only thing that I remember. 2x squared. Help me, please.
Plus 3x.
Plus 3x. Mm-hmm.
Plus 2.
Plus 2 all over.
Plus
2x
1.
plus 1. Thank you, Freddy. So nice. Okay, guys. This is my function. Okay, now it's time to set, guys, which values I'm gonna take to the left and right of my vertical axis. Take a look, guys. In the three cases, we use the same idea with the table. What is the only difference that changes according to the case? Is the horizontal axis. So that's the only thing that is going to be, varying. Okay, which values can I take to the left of this point, guys? This is the point, -1/2. Okay, tell me, guys, two numbers to the left of this point. It could be -1 and -2, or -2 and -3. Okay, I'm gonna take -3. Let me see, -3 and -2. Okay, now you can take -1 too. Now tell me two values, guys, to the right of this. We are here. 0. Guys, if we can take 0, let's take it because it's the easiest one. 0 and what another one? What another? 0 and 1. Okay, we can take 0 and 1. Okay, let's zoom in here and let's substitute this. Please use the calculator. I don't have mine. I'm gonna need you to help me with that. Okay, 2 parentheses square plus 3 parentheses plus 2 all over 2 parentheses plus 1. Okay, the value, guys, for x in this case is gonna be -3. Okay, we're gonna put -3 in all of these parentheses. -3, -3, and -3. Okay, let's see what we're gonna get. In the calculator, guys, please write all of these, okay, all of this like this. After this, guys, put divided by in parentheses for this, okay? If you don't put parentheses, the calculator is going to misunderstand you, okay? Tell me, what do you got out of this? Oh my gosh. 11.6, guys. You got that? Please, can someone tell me?
I got 8.6.
Oh my gosh, there is a mistake, so I don't know. Okay, I'm gonna do it again. I'm gonna do it again. 2 negative 3 squared plus 3 negative 3 plus 2. Okay, now divided by, okay, for these guys, for the denominator, I put parentheses. Okay, open parentheses, I open parentheses here, and I put here 2 minus 3 plus 1, and I close parentheses. Okay, close parentheses. Okay, 8.6. Okay, thank you. This is yours. Okay, you were right. Okay, 8.6. Thank you. Okay, let's do it with negative 2. I'm going to stop the video, guys, but it's going to be exactly the same. Okay, 0. Okay, now we're going to substitute 0, guys. I like to do this with 0. Okay, take a look at with 0, guys. You don't need to use all and compute all of these values on your calculator. Why? Because, guys, this 2 times 0, this is 0. 3 times 0, this is 0. 2 times 0, this is 0. What do you got, guys? 1 over 1. What is 1 over 1, guys? 1 divided by 1 is 1. Piece of cake. Okay, the last one. Let's substitute 1 here. Okay, and let's see what we're going to get. Okay, we can do it mentally. 2 times 1 is 1. 3 times 2 is 3. 3 plus 2 is 5. 5 plus 1 is 6. 6 over 3. I think it's going to be 2, guys. Please let me know it if I'm right or wrong. I think it's 2, guys. The last one with 1. Just let me know it if I did it right or wrong. Freddy, am I right?
I got 5.6.
My gosh, okay. I don't believe in myself. Okay, let's see. 2 to the, okay, this 1 to the second power is 1. 2 times 1 is 2. Plus 3 to the, okay, let's use the calculator instead. Okay, 2 times 1 to the second power plus 3, 1 to the second power plus 1, all over 2 plus 1. 2 times 1 is 2, plus 1 is 3. I think it's 2. Freddy, check it out. I get 2 again. Okay, now if I had a mistake, I'm gonna see in the graph, because when we plot a point with a mistake, okay, we know that something is squared. But I think it's right. Okay, let's plot this point, guys. Negative 3 with 8.6. Okay, negative 3 with 8.6. Okay, we don't have 8, guys, but it's going to be a point like, I mean, really low here, right? Okay, let's put it. Let's say that the point is something like here. Okay, approximately, but it is not exactly, because we don't have it in this coordinate system. Negative 2, guys, goes with, oh, no, 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 sorry, guys, my mistake. I'm using the negative side, right? And it is positive. Okay, mister, shame on yourself. Yeah, negative 3, guys, goes with, okay, 8.6 is gonna be extremely up, guys, extremely up. Okay, I was taking the wrong side. Help me, please, correct me. Okay, it's gonna be a point like this. Okay, negative 3 with 8.6. Okay, it's gonna be something like this. And now negative 2, okay, negative 2 with 1.3, okay, negative 2 with 1.3, it's going to be a point here up, okay, 1.3, okay, something like this. And let's go to the other side. 0 for x, okay, 0 for x, how many for y? 1, right? Okay, it's going to be a point here. I'm going to zoom in. 0 for x and 1 for y. Okay, it's going to be a point like, let me see, something like this. And the other one, guys, 1 for x and how many for y? 1 for x and 2 for y. Okay, it's gonna be here. It's gonna be here. Okay, and now, guys, we can graph this. Okay, how we're gonna do that, guys? Take a look. We know that this is my oblique asymptote. The graph is going to be approaching to that, and this is another asymptote. Okay, let's graph the first part. Take a look how we're gonna graph this out. Okay, let me see if I can graph that. Okay. In this case, I don't know which color can I use to make a good graph. You want to try to use this one. Take a look at this point, guys. The graph is coming from this, from up, 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 up. It's coming from this to this point. I don't know what is going to happen here because I don't have more points, but I know this is an asymptote, okay? This graph is going to be approaching to this, okay? This graph is going to be approaching to this in a way like this, okay, to the infinite. And just that. And what about this part, guys? What about this part? Okay, let's zoom in here a little bit. And it's going to be the same. Okay, the graph, guys, is going to be going here, going here. And here, guys, is going to be approaching to this asymptote too. Okay. And this is, it looks a little bit weird, but this is more or less how the graph is going to be like. Okay, I repeat, this line, okay, this line, I'm going to make it color in this part. Okay. This is, this is how I can sketch this graph. Okay, if there is any question, guys, just let me know it.